Assalamualaikum and greeting to Dr. Nur Aliza. We are from Group 4 of Hydraulic BFC 21103, Semester 2, 2020-2021. My name is Hani Yusrinam Desaini. My members' name are Nur Akila binti Salim, Izzah Nur Hayati binti Sidik, Muhammad Nur Azad bin Badli, and Nur Ala Izzati binti Mat Zaini.
The introduction. Roadway play an important role as the land transportation for humans to move from a place to another place easily. So roadway drainage system will to remove the water from the road. So it applies the concept of draining water to the nearby stream that can avoid the rainwater on the surface of the road. Usually the water came from the rainfall, and the water needs to be discharged to ensure the safety of the road user and avoid the accident due to the slippery of the road that caused by the rainwater. There are two natural phenomena that can cause flood, which is heavy rainfall and water from hills. So for the heavy rainfall, it can cause the flood on the surface of the road. And when the flood occurs, it will affect the human and organic. For human, it will affect their accommodation, and for organic, it will affect their habitat. So clogged drain that caused by human also can cause the flood, which is human always throw their rubbish on the drain, so it will damage the road drainage. So for the water from hills, so soil absorb the water from the rain. So when the soil have sufficient amount of water contents, and it will lose their strength, and the landslide will occur. So to avoid this circumstance, the effective drainage system need to be built to at the hills so we can avoid the landslide. So the aim of our project study is to design the suitable drainage system that can avoid the flood at Kampung Sungai Yap. So the effective drainage system need to be considered to reduce the damage of the drain system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alizati binti Mat Zaini and my thermometry is AF200045. Today I would like to present study area for our group project. The study will be conducted in Kampung Sungai Yap, Cerantut, Pahang. The drainage plan for our study area is a 225 meter long street starting from channel 375 to channel 600. This is the drainage plan from channel 0 meter to channel 600 meter at Cerantut, Pahang. We have three objectives for our group project. Firstly is to determine and label the type of drain suitable along the proposed road for the chosen drainage based on the standard given. Next is to analyze and sketch the direction of flow within the drain along the proposed 225 meter road. Next is to design the size for a chosen drain system with consideration of rational method for 20-year ARI event of Kampung Sungai Yap rainfall station. For methodology, this is the general procedure for estimating peak flow using the rational method. Firstly, we need to select design ARI. We need to select design ARI for drainage system. Next is discretize subcatchment. In this step, we need to divide the subcatchment into segments of homogeneous land use or surface slope. So it will be easier for us to calculate. Next, we need to estimate time of concentration, TC. In this step, we need to estimate overland flow time, and then estimate flow times for all other flow components within the subcatchment, such as cup gutters, pipe, and channels, etc. Next, we need to determine average rainfall intensity, which is I. So, to calculate in this step, we need to calculate I for design ARI and duration D equal to the time of concentration from IDF data for area of interest. Next, we need to estimate runoff coefficient. In this step, we need to estimate C values for each segment if there are different land uses. Next is to calculate the average runoff coefficient. In this step, we have the formula, so we just substitute the value into the formula. So for the last one, we need to calculate peak flow rate Q for the subcatchment. In this step also, we have the formula, so we just substitute the value into the formula.
Next, for the results analysis, from this slide you can see on the left side we have the layout plan of the drainage, while on the right side we have the cross section of drainage of 550. For the calculation, we will use the example from cross-section chainage 550. The first one, we will find the length. Top offset minus rod offset, the answer is 10.748 meter. For the height, we will use top finish level minus the bottom finish level, and the answer is 4.124 meter. For the new length, we will use the formula of SERT L square plus H square, and the answer is 11.512 meter. For the friction slope, slope is equal to height divided by length, and the answer is 0.358 mm. For the catchment area, we get 202.78 m square. This slide shows the data table from slope. For the chainage 550, the height is 4.124, the length is 10.748, the slope is 0.358, the new length is 11.512, length chainage 25, and area is 202.78. While this slide shows the data table from road, for chainage 550, the height is 0.0625, the length is 6.250, slope is 0.01, new length is 6.250, length chainage is 25, and the area is 156.250. This slide shows the type for surface road drainage. It shows either the earthwork needs to cut or fill. And for the type of surface road drainage, it was between embankment toe drain, berm drain, shoulder drain, roadside drain, bench drain, and interceptor drain. Calculation of flow path length and travel time. For the flow path length, we can use this formula to find the flow path length. And here, the flow path length is equal to 13.074 meter. For this one, we will determine the slope of overland surface in percent. So, to find the slope, we will use this formula to find the slope of overland surface in percent. And here is 36.8%. For the travel time, we will use the formula of 107 multiple n multiple L to the power of 1 over 3 divided by S to the power of 1 over 5. And the answer for travel time is 5.52 minutes. This is the table data of flow path length and travel time. From slope, we can see the chainage to 525 to 550, the slope percentage is 36.5, flow path length is 13.074, Horton roughness is 0.045, and the travel time is 5.52. From wood, from chainage 525 to 550, the slope is 1%, flow path length is 6.250, Horton roughness is 0.015, and the travel time is 2.956.
Table 5.5 Calculation of time travel in channel. Untuk length, kita guna panjang 25 meter. Untuk slope pula, kita dah kira nilai slope dalam table 5.3 and kita just ambil value daripada table 5.3 dan masukkan dalam table 5.5. And untuk meaning coefficient, kita guna nilai 0.015 sama untuk semua keratan. Untuk radius, kita guna rumus R equal to A over P and we will get the value is 0.205. And nilai ini adalah sama juga untuk setiap keratan. Tapi untuk nilai time, kita berbeza untuk setiap keratan because kita guna nilai N, kita guna rumus N times L divided by 60 times R the power of 2 over 3 S the power times S the power of 1 over 2. So NL kita guna nilai yang sama 0.015 time dengan 25 panjang divided by 60 time dengan R. R tadi nilai dia adalah sama untuk setiap keratan. Jadi R digantikan dengan nilai 0.205 and S berbeza untuk setiap keratan rentas. So saya bagi contoh untuk change bagi 375 sampai 400 which is nilai slope dia, nilai S dia adalah 1.199 and bila kita masukkan dalam rumus, kita akan dapat nilai dia punya T adalah 0.016.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hussein Hayati. I am going to explain about the disebabkan fungsi, the calculation of time concentration. So to identify the value of TC, we need to substitute the value of TD and T0 into the equation of time concentration, which is time travel added with time travel infinite. So for value of T0 and TD in slope partition, we can be obtained from previous calculation, while for T0 and TD for drain partition are all constant since our drain are uniform.
Next is left side and roadside drain. The design of average recurrence interval or ARI can be interpreted by the formula of the average rainfall intensity. We need to find the value of average rainfall intensity using the formula given within the average recurrence interval of 20 years. And by substituting the value into the equation, we will obtain our average rainfall intensity as 2081.39 mm per hour. And so for peak flow is the key parameter in choosing a suitable drain by using the formula of Q equal to CIA over 360 to find the Q hydrology for both road and slope. So the value of Q hydrology for slope is 0.095 meter cube per second. For calculation from road are both same with calculation from slope. And from road we can obtain the value of average rainfall intensity as 2081.39 mm per hour and Q hydrology from road as 0.088 meter cube per second. This is the tabulation of data from previous calculation of Q hydrology from slope and from road. And now we need to analyze the dimension either it suit within the recommended limits or not using the equation of discharge. Since the Q hydraulic obtained are 0.9113 meter cube per second, where the value of Q hydraulic obtained are larger from the Q hydrology, we can tell that the drain dimension are within the recommended limits.
So this is the table of calculation of drain size and discharge Q hydraulic. So as we can see, the area, the width, perimeter, hydraulic, radius and manual coefficient, we use the 0.14, 1.125, 0.124 and 0.035 respectively. So to find the longitudinal slope, we're using the previous percentage slope, and we divide by thousands. So as we can see, the channels from 375 to 600. So the characteristic of Q hydraulic is bigger than Q hydrology. In this table, we can see that all the channels is passed. So it can conclude that the drain is suitable to build in Kampung Sungai Yap.
For discussion, we consider road from change 375 to change 600 according to either it is cut area or fill area. Choosing drain category for each part is based on the highest level by referring the cross section. For Q hydraulic calculation, we use 0.035 as mean roughness value as we design it as rough surface concrete drain to reduce the rate of flow for all drain type. For calculation Q hydrology, we need to decide the runoff coefficient based on the topography map given. Through our observation, it is an open channel land with grass cover. So our runoff coefficient value for all drain is 0.5.
Conclusion, the 225-meter drainage system for Kampung Sungai Yap was planned in line with lag practices of JKR standard drawings for roadwork section 3 drainage works revolution 2014 and JPS urban stormwater management manual for Malaysia 2nd edition 2012. The proposed design of the drain involves standing water levels to extend the highland region, as well as to replace lowland soils along the drain line, with a view to enhancing the percolation of stormwater and ensuring an acceptable level of water than was the case prior to construction. In order to ensure that the drainage can be quickly and smoothly drained from 375 meter to the 600 meter, the drainage runs according to the graph flow from the plan and the longitudinal profiles given. The drain type used is roadside drain type 2, and by referring to the flow rate calculation, the drain can accommodate the rainfall intensity. Thus, the proposed drain is suitable for the roadside drain.